Yesterday I found out that tomorrow the other class, Tuesday, Thursday class is on. They have campus closed tomorrow, so I will not have class tomorrow. Now instead, at the same time, I think I already told you that I will not do all tests anymore, all test one anymore for this Wednesday. So what I will do instead, what I will do instead is I will continue what I taught yesterday at in that Tuesday, Thursday class to Monday, Wednesday, this Monday, Wednesday. So let me just write down what I had in mind. So on Monday, Wednesday, last time we did, I think spring 20th, math 2 test 1 solution. Let me check. Let me check. I think that's the one we did last time. Yeah, spring 20 math 2 test 1 solution. Okay, so what we will do today, we will continue from math 2 Tuesday, Thursday, the one yesterday. Okay, so because we are actually behind by 1 day anyway. So this is what I will do now. I will finish up 3.1 that we did yesterday, and then go on to 3.3, the parts that we can do without you watching lesson 10. Okay, without you watching lesson 10, there are parts of lesson 10 that we can do already. Okay, so Tuesday, yesterday we did 3.2 and part of 3.1. Okay, now tomorrow they have no class. So what I originally planned to do yesterday, 3.1b, I think I should say what I originally plan to do tomorrow, which is 3.1b and 3.3a, that's what I will do right now. After all, we are done with the material to review our test 1. Okay, so if you are here to review test 1, you can watch the recording from the last Monday, Wednesday class from the last 2 weeks, I think. Okay, but you can watch this recording here in place of Tuesday, Thursday discussion. Okay, now I will continue from what we did yesterday. Yesterday we did 3.2 first, and then after that we did part of 3.1. The one I cross out here are the problems we have done from 3.1 yesterday. Now I will continue. Number 21. From 3.1, the question is find all values of x such that fx is greater than 0 and all x such that fx is less than 0. Okay, now number 21, the fx is negative x cubed plus 2x squared plus 8x. Solution. Now, if you pay attention, if you already watched the recording from yesterday, Tuesday, Thursday class on Tuesday, yesterday, then you see our plan will be pretty much as the following. We'll do 3-step procedure that we use to solve polynomial inequality, okay, but only up to step 2. Okay, let's see. What are those 3 steps? The first step, we find the critical number. The second step, we do the sine graph. And the third step, the solution. Now, what we need is actually the sine graph. Okay, what we really need is the sine graph. Then we proceed with the solution for fx greater than 0, for fx less than 0. Okay, now let's see. Step 1. Step 1, we find the critical number first. So fx equals to 0, negative x cubed plus 2x squared plus 8x. Okay, I think we can factor the negative x out. And then factor further. So the critical numbers are x equals to 0, x equals to 4, and x equals to negative 2. Now then next we do sine graph. Negative 2, 0, 4. Now those are the critical numbers, right? And for the polynomial, so they give us zeros, right? And now then we do testing point. When x equals to 1, for example, when x equals to 1, what happened to f1? f1 is negative 1 cubed plus 2 times 1 squared plus 8 times 1. That will be negative 1 plus 2 plus 8, that's positive 9. That's positive here. And because each of these critical numbers has multiplicity of 1, you see the exponents are all exponents 1s in the factors. Now, therefore, when we jump across the critical number, we change the sign. Okay, basically, the critical number are all, in this case, multiplicity of 1. Then, because it's odd, then when we jump across the critical number, we change the sign. Okay, now, at this point, then we can answer the question. At what x will fx is positive? Fx is positive on which interval? It is positive on this interval and this interval, right? It is the function is positive on negative infinity up to negative 2 union from 0 to 4. Okay, now mind you that when we graph this later on, which is what we will do, okay, I will have follow-up question from there. Once we have defined the sine graph, then we will be able to sketch the graph actually. Okay, we can sketch the graph with some the x-intercept and the y-intercept already, and how the graph behave above or below x-axis. Okay, now continue. How about when fx is negative? Fx is negative on this interval. Fx is negative on the interval from -2 to 0 union 4 to infinity. Okay. I hope you are following me with my writing here. Yeah, let's copy this down first so that you can see the details once I start doing the graphing. Okay, I'm about to graph this. Okay, let's say this is my x-axis and this is my y-axis. Now, let's see what's the x-intercepts of that function. The x-intercept of that, the y-intercept of that function is, maybe I write it down first, y-intercept. When x equals to 0, you see the y is 0, right? Now, how about the x-intercept? The x-intercept has something to do with the critical numbers we have above. Because we were actually solving for y equals to 0, right? When y equals to 0, what's the x? So we get the zeros of that polynomial. Okay, now that's what I use here. Then the x-intercepts will be 0, 0, 4, 0, -2, 0. Is it okay? Now then let me plot those. The x-intercept, the y-intercept happens to be an x-intercept also. That's 0, 0, 4, 0, -2 zeros. This is -2, this is the origin, this is 4, 0. Now then notice that to the left of x equals to -2, the graph is actually above x-axis. Between -2 and 0, the graph is below x-axis. Let me mark it. So this is the one above, right? You see, compared to this here. Okay. Now, then between -2 to 0, it's below x-axis. From 0 to 4 is above x-axis. And from 4 to infinity, that's below x-axis. Okay, so this is above x-axis, this is below x-axis. Okay, now that's the sketch of the graph. Now we can confirm something. We can confirm something, another follow-up notes. Another follow-up note is that notice that the fx is -x cubed something, right? So what happened to the far end behavior? Yeah, far end's behavior only follow the leading term, right? And the leading term here has degree of 3, and the leading coefficient is negative. If you memorize, then the graph's supposed to look like this. In other words, when you go to far right, when x goes to infinity, the function goes to -infinity. If you go very, very far to the right, the y gets to -infinity. When you go very far to the left, the y goes to +infinity. Our textbook don't use this notation or this sketch from the -infinity, it's going to top If you go very far to the right, you go to the bottom. Our textbook actually use a more precise notation. Our textbook use the following notation. Our textbook will say, okay, limit x goes to positive infinity of fx is negative infinity. Okay. Or at times, our textbook use as x goes to positive infinity, fx goes to negative infinity. That's the right end behavior when you go to very far to the right. And when you go very far to the left, limit x going to negative infinity of the function fx, that will be positive infinity. In other words, when you go very far to the left, as x going to negative infinity, the function fx goes to positive infinity. Okay. Now, in my class, I will just call this top bottom. Means when you go very far to the left, you go to positive infinity, the top. When you go very far to the left, you go to the top. When you go very far to the right, you go to the bottom. Okay. That's in my class. So in my class, when I ask you what is the far end behavior, you can answer this way. You can answer using this. You can answer using this. You can answer using both of these. Okay. Now that's for number 21. So notice that they give us the function. They give us a function, which is degree of 3. This is not degree of 2 anymore. Quadratic function is something we already know how to graph, right? Okay, but what happens if we have higher degree? Yeah, what happens if we have higher degree? Can we graph that further? And the answer is yes, supposed to be. Okay, we are supposed to be able to graph that further if we can factor them. Okay, so notice that from my lesson, my lecture yesterday, I sketched for you the following information. Oh, hold on. Yesterday, I said this. Polynomial P C is equal to 0 by definition means C is a 0 of Px. Okay, now, so if we can solve Px equals to 0, then we will get the zeros. Now, if C is a 0, then by factor theorem, x minus c is a factor of Px. Okay, now the thing is, if C is a real number, so this is a big one. If C is a real number, not a complex number, then C comma 0 is an X-intercept of the graph of that polynomial Px. Okay. And remember this diagram. Remember this diagram. Remember this diagram. It actually tells us a lot about the strategy we use in 3.1, 3.2, 3.3, and 3.4. Okay, we play a lot with this. Okay, now for now, this is what we need. Once we get to 3.3, then we will do more. Okay, we will extend this diagram a bit further. Okay, let's see number 25. Number 25, we have fx equals to x cubed plus 2x squared minus 4x minus 8. This one we can solve by factoring, right? We can solve by factoring, but our question, just like before, expect further. They want us to do the sine graph so that we know at which interval the function is above and below x-axis. Okay, so our step one, the critical number. Okay, notice that this is the same procedure to just the step one to find x-intercept. Okay, so we set the fx equals to 0 and we solve for x. Okay. And then we can factor this by grouping. So this is x squared times x plus 2 minus 4 times x plus 2. This is x squared times, oh, I'm sorry, x squared, no, not x squared. The common factor is x plus 2. So x plus 2 times x squared minus 4, which is x plus 2, x plus 2, x minus 2. For sake of completeness, let me write it as x plus 2 squared, x minus 2. Now from here we see that the zeros of this function are x equals to -2 with multiplicity of 2. Okay, from here you get this. The multiplicity of 2 comes from the exponent. Okay, and we have another 0, x equals to 2, which comes from here. Okay, now why do I have to note the multiplicity? Because it will affect how we do the sine graph later on. So notice that if you don't write the details since the beginning, then you will lose even more details later on. Plenty of time you get stuck in math problem because you don't write down what you know, but you also cannot write anything you don't know. Right? Simply because you know it doesn't mean you don't write it down. Write it down so that it becomes a note that you can use for future follow-up question. Okay, so the multiplicity of 2 here is something I want to emphasize that I will use later on. But before we go on, notice that if the zeros are -2 and 2, both of them are real numbers, then consequently the x-intercepts are -2, 0, 2, 0. Now, I have emphasized many times that any intercept is a coordinate. Intercept should be written as a coordinate. But hold on, Thomas. The zeros you have here basically implies that's an x-intercept. Yes, in this case, but not all zeros are translates into, not all zeros node. I mentioned this in yesterday's lecture. Okay, let me mention that again here. Note, not all zeros translate to X-intercept. Okay, so far that's what we see, but that's not true. That's not all zeros becomes X-intercepts. Okay, all X-intercepts must come from zeros, but not all zeros comes from X-intercept. Okay, now the example we have here, all the zeros, which are -2 and 2, okay, becomes X-intercept -2, 0 and 2, 0. However, it is not true in general. Why? Let's take a look. Okay, for example, if we have let's say px equals to x to the 4th minus 16. So if we try to find the zeros, we set this px equals to 0, right? And then we factor it, x squared plus 4, x squared minus 4. Right? And we can factor further x squared minus 4, but x squared plus 4 cannot be factored further. Right? So what are the zeros? X squared plus 4 equals to 0, x plus 2 equals to 0, x minus 2 equals to 0. So x squared equals to -4, x is plus minus square root of -4, which is plus minus 2i. Okay, x equals to -2, x equals to +2. So what are the zeros? The zeros are x equals to 2i, x equals to -2i, x equals to -2, and x equals to 2. Okay. Now, however, because these 2i and -2i are not real numbers, then they will not be sketchable. You cannot plot not real number on a real coordinate system. Okay, so even though we have 4 different zeros, only the real part translates into X-intercepts. Okay, only the real parts translate into X-intercepts. The one non-real complex number, okay, cannot become X-intercepts. Okay, that's why zeros and X-intercept are not the same. Okay, you may have seen in the recording, either from last semester or even previous semesters, that I have some students try to talk to me into accepting their notion that X-intercepts are just zeros. So the way they write X-intercept, they just write numbers. X-intercept, x equals to -2, X-intercept, x equals to 2. And I penalize them for that. Okay, the reason I penalize is exactly for this reason. Okay, because basically zeros and X-intercepts are not the same. What you call X-intercepts is actually just the zeros. Okay, but not all zeros are X-intercepts. Not all X-intercept must be 0, but not all zeros are X-intercepts. Okay, now to differentiate that, X-intercepts must be written as a coordinate. Okay, anyway, going back to that number 25. Okay, the purpose of this number 25 is to find all x where fx is positive and all x where fx is negative. Okay, I know I spend a lot of time on this because I want you to see the details. Now, but with some practice later on, especially if you follow my lectures and also follow it in writing, you can do it a lot faster later on. Okay, because at the same time, I need to remind you of your factoring. What happened if it is not factorable, right? And what happened if this? What happened if that, right? Okay, now here we have critical numbers, -2 and 2. Remember, -2 is a critical number with multiplicity of 2, even multiplicity. Now we test points. How about when x equals to 0? When x equals to 0, that's basically the y-intercept, right? That's basically the y-intercept. The y-intercept will be 0, -8, right? Just a constant. Just a constant. Okay. Let me put an arrow so that you know what I'm referring to. I don't like that. That's way too thick. Why it doesn't work? Okay. Now then, so coming back here, we see, oh, the y-intercept is 0, -8. So when x equals to 0, the y is negative. Now 2 is a 0 with odd multiplicity. So when I jump across that critical number, I change the sign. However, when I jump across -2, -2 is a critical number with even multiplicity. So I don't change the sign. Okay. The reason I still go over this, even though this material is already in your test too, but implicitly the skill you need to have to do the material here are the skills you need for your test 1. That's why I just go over that right now. This is already material for your test 2, but the skill you need here and there are actually from test 1. Okay, now step 3. So we can say, so the function is positive on interval 2 to infinity. The function is negative on -infinity to -2, not including -2, union -2 to 2. Okay, now actually then we are ready to sketch. So that's the follow-up question. That's the follow-up question. Let's sketch this. Actually, no, we have the y-intercept actually -8. So let me draw it this way instead. So the y-intercept is 0, -8. X-intercepts are 0, -2, and +2. Now, the functions are negative when it is in this interval from 0 to -2, right? And between -2 to 2, those are negative. And it will be positive from 2 to infinity. Okay, so it's positive from 2 to infinity. It's negative from -infinity up to -2 and then -2 to 2. So when we try to graph that, you see that the graph actually looks like this. Okay, and it's actually bouncing at -2. Okay, that's for number 25. Now let's do more. Let's do more. Number 29. Number 29. So fx equals to x squared, x plus 2, x minus 1 squared, and x minus 2. Oh, they already factored it for us. Great. Okay, so let's see the critical number, or basically the x-intercepts later on. Okay, I set that function to be 0. So you see that x equals to 0 with multiplicity of 2, x equals to -2 with multiplicity of 1, x equals 1 with multiplicity of 2, and x equals 2 are the zeros. Now, the consequence is that this later on becomes your x-intercepts. Okay, the x-intercepts are 0, 0, -2, 0, 1, 0, 2, 0. Okay, those are the x-intercepts. Now, the concept of multiplicity actually with the zeros. So when we say, what are the zeros? The zeros are x equals 0 with multiplicity of 2, x equals -2, x equals 1 with multiplicity of 2, x equals 2. Those are the zeros. Now, when we answer the x-intercepts, we don't need, and actually not supposed to, give the multiplicity. So when they ask you, what's the x-intercept for this function? You will just say 0, 0, -2, 0, 1, 0, 2, 0. You don't need to tell and not supposed to tell the multiplicity. Okay, now that's for step 1. Step 2, we will create the sine graph. -2, 0, 1, and 2. 0 is a 0 with multiplicity of 2. 1 also a 0 with multiplicity of 2. Okay, now we do testing point right now. Let's say x equals to 5. X equals to 5. So what will f5 be? F5 equals to 5 squared times 7 times 4 squared times 3. Well, it doesn't matter. It's all positive, right? Now, 2 is a critical number with odd multiplicity, so I change the sign here. 1 is a critical number with even multiplicity, which means I don't change the sign here. 0 is a 0 with even multiplicity, which means I don't change the sign here. -2 is a 0 with odd multiplicity. I change the sign here. Okay, so now we can answer. So the function fx is positive on the interval -infinity up to -2 union 2 to infinity. the function fx is negative on which interval? -2 to 0, union 0 to 1, union 1 to 2. Okay, just like before, I told you, you need to, when you do the sine graph, make sure you put the zeros here. You need to put this, okay, so that you can explain why you don't include the endpoints here. Okay, why don't you include the endpoints for that 0 or when x equals to 1? Because what we need here is fx to be negative, not including 0. Okay. Now, so if I use color to help me, then I get this. The function where the interval where the function is positive is on this interval, union that interval. Okay. And the function is negative on this interval. Notice that I purposely not shading the critical number, because on that critical number, fx equals to 0. Okay, now then, as a follow-up question, suppose I want to sketch the graph. Sketch the function y equals to fx. Now we already have the x-intercept and actually also the y-intercept, right? The x-intercepts are, there are a lot of x-intercepts here, but the y-intercept is 0, 0. The y-intercept is 0, 0. X-intercepts are -2, 0, 0, 0, 1, 0, 2, 0. Right? We already have it up there, here, x-intercepts. Okay, and the y-intercept happens to be 0, 0 also. So then where does the function above x-axis? It's above x-axis to the left of -2 and to the right of 2. It's below x-axis on -2 to 0, 0 to 1, 1 to 2. Okay, so to the left of -2 is above x-axis. Between -2 to 0, it's below x-axis. However, it goes back to 0. From 0 to 1, it's still below x-axis, so it's bouncing. Still below x-axis. To the right of 2, it's above x-axis. That's the sketch of the graph. Okay, now in calculus later on, then once you go to calculus, then you need to find the coordinate here. Then you will find the coordinate here once you go to calculus. Okay, but that's not what we are doing right now. We don't do that right now. Okay. That's for number 29. Number 31. Implicitly already taught. Number 31. Let me do it here. They give you the sine graph. They give you the sine graph. We have -4. We have 0, 1, 3. Okay, and then they use lines for zeros. Okay, and then the sign here is negative. This is positive. This is negative. This is negative. This is positive. Okay, that's from our textbook. That's the question. Now, what they want us to do is, given this sine graph, the following sine graph, sketch the function. The graph of the function. Then I basically follow that. Okay, so let's say this is the x-axis. And this is the y-axis. I purposely make it match with 0. Okay, and then this is x equals to -4, x equals to 1, and x equals to 3. We have critical numbers in form of zeros at -4, 0, 1, 3. Now I want you to associate it this way. Take a look. Take a look. I will erase this later on, but you see that -4 associated to this critical number x equals to 0 associated to this, x equals to 1 associated to this, and x equals to 3 associated to that. See that? Okay, now then the graph is positive or -infinity to 4 and 1, 3. So on this interval here and here, it will be above x-axis. Will be above x-axis. Okay, while the one here will be below x-axis. Let me use green instead. So here below x-axis, below x-axis, below x-axis. Okay, so the graph will be below x-axis, going back to critical number, below x-axis, going back to critical number, and then you go down like that. That's what the graph looks like. Okay, that's for number 31. Let's see what other question I need to do. Oops. Number 33. Number 33, sketched a graph of, number 33, sketch a graph of fx equals to x minus a, x minus b, x minus c, where dA is less than 0, less than b, less than c. Okay, so let's do the sine graph first. The sine graph will be the critical numbers are a, which is less than 0. B is greater than 0. So this will be our testing point later on. This is x equals to 0. It's between a and b. Okay, and c is even to the right of b. Those are the critical numbers, right? Okay. Actually, I won't be able to answer this for now. I need to find the y-intercept first, which is part B. Which is part B. What? Find the y-intercept. Hold on. What happened? Y-intercept. Okay, what it says, F0. F0 equals to negative A times negative B times negative C. That's negative ABC. Now, my question to you is this negative ABC positive or negative? Is negative ABC positive number or negative number? Now, is A positive or negative? Notice that A is less than 0, right? So A is negative. Therefore, negative A is positive. Is it right? So this guy here is positive. B is greater than 0. C also greater than 0. Basically, all of these are positive numbers. Right? Negative A is positive times positive, then it will be positive. Okay, so this is positive. This is positive. This is positive. Okay, so the y-intercept is 0, comma, negative A, B, C, but we need that positive part. We need that positive part for this here. Okay, now then, B is a critical number with simple multiplicity. That's a simple 0, means multiplicity of 1. I change the sign. C also, I change the sign. A also, so I change the sign. Okay, so we can answer part C now. We can answer part C now. What is the solution to fx equals to 0? Fx less than 0 is when it's negative, right? When it's negative here. Here and here. So fx is negative on interval negative infinity to A union B to C. Now part D. What is the solution for fx greater equals to 0? It's greater equals to 0, including the endpoints, Okay, that's for less than 0. Okay, and this is for greater equals to 0. We have from A to B, including the endpoints, union C to infinity. Including the endpoints because we have fx greater equals to 0. Okay, now using that sine graph that we already have in part A, we can sketch the graph, which is what they want us to do. What they want us to do is to sketch that graph. Okay, x-intercept are A, 0, B, 0, C, 0, and the y-intercept is 0. This is A, 0, B, 0, C, 0, and the y-intercept is 0, negative A, B, C. Now, negative A, B, C doesn't have to be a negative number. Simply because you see negative in front of that doesn't mean it's negative. Okay, like in this case, the A is negative such that negative A becomes positive. Okay. Now, then what happened to the graph? To the left of A is below x-axis. Okay, above A, it's above x-axis. Between A to B is above x-axis. Between B to C is below x-axis. Between C to infinity is above x-axis. Okay, that's for number 33. Number 35. We get more into theoretical problem. Number 35. Let fx be a polynomial such that the coefficient of every odd power of x is 0. So a polynomial in general has this form: a sub n x to the n plus a sub n minus 1 x to the n minus 1, a sub n minus 2 x to the n minus 2, so on and so forth until we get a sub 2x squared, a sub 1x, x sub n, and x a sub 0, which is a constant. Now, in this question, they want that the coefficient for even exponent. Give me a second. So for even exponent of x, actually, the coefficient of every odd exponent, so not even, is odd. For odd exponent of x, odd exponent of x, set the coefficient to be 0. Okay, notation wise, we can write it this way: a sub I equals to 0. The coefficient for exponent I is equal to 0 for I equals to odd. Okay, so basically, if you set it that way, then your polynomial now becomes a sub n x to the n plus a sub n minus 2 x to the n minus 2, so on and so forth, a sub 2 of x squared, a sub 0. So no more odd exponent. Okay, or they call that fx, so change that to f. They call that fx. Okay, so n is even. Now show that this function is an even function. Show that this function is an even function. So let's take a look what is f negative x. Okay, it is even function if, let's remind ourselves, fx is even if and only if f negative x equals to fx. Okay, because a function is even if and only if it has y-axis symmetry. If it has y-axis symmetry. Yeah, this question tried to explain why do we call that even function. Okay, why we call that even function? Well, because if that function is a polynomial, the exponents of the terms in the polynomials must be even. Okay, so a sub n negative x to the n plus a sub n minus 2 negative x to the n minus 2 all the way to a sub 2 negative x squared plus a sub 0. Okay, but because n is even, then negative x to the n will be just the same to x to the n. Negative x to the n minus 2, which is still even exponent, right? Then it won't change the sign. Now we see that when we replace x by negative x, the function simplifies into the original function. Okay, so fx is even. Okay. Now, if we have a function is a polynomial, not for other. If the function is a polynomial, then it is an even function. The polynomial is even if the exponent of all the terms are even. Only if it is a polynomial, not when it is rational. Not when it is rational, not if in other case. Now, this question here is very, very theoretical, very conceptual. Okay, very conceptual. But the reason I want to go for this question is because we want to know where that even word in even function coming from. Now, the function is even, a polynomial is even if the polynomial consists of terms with even exponents. Okay, why? Because if you replace the x by a negative x and the exponent is even, that will be just x to the even power, the same even power. Okay, that's for number 35. Number 37. Number 37, if fx equals to 3x squared minus kx, I'm sorry, 3x cubed, not 3x squared, 3x cubed minus kx squared plus x minus 5k, find a number k such that the graph contains negative 1, 4. Find k such that the graph contains negative 1, 4. It's a conceptual question, but it's actually not too hard. Why? Because negative 1, 4 is on the graph, right? In other words, if I replace the x by negative 1, if I replace x by negative 1, it should be equals to 4. That's what it means. Okay, so 3 times negative 1 minus k times 1 plus negative 1 minus 5k equals to 4. Let's compute that. Negative 3 minus k minus 1 minus 5k equals to 4. So negative 6k minus 4 equals to 4. Negative 6k equals to 8. K equals to 8 over negative 6. Then the k is negative 4/3. That's not too hard. Okay, the last one, number 39, I think that's the last question. Is it? Let's see, yeah, number 39 is the last question that I want to go over in this section. If you take a look in my lectures, in the lessons, like on announcement 5, you will see that I never really have a chance to do or to go over such theoretical problem. Okay. A theoretical problem is useful for us to understand the concepts even further. Okay. Let's see. Number 39. Let fx equals to x cubed minus 2x squared minus 16x plus 16k, and one of the zeros is 2. The question is, find 2 other zeros. How do we know that there should be only 2 other zeros? From fundamental theorem of algebra that we will see in 3.3. This is a polynomial with degree of 3. So it should have 3 zeros. Okay, one of them is 2. One of the zeros is 2. Then can we find other zeros? Okay, we already learned syntactic division, right? Okay, we already learned syntactic division. What happened? Why it looks like that? Okay, we already learned syntactic division. If 2 is a 0, c equals to 2 is a 0. Give me a second. Let me erase that. It's kind of annoying for me. Yeah, if 2 is a 0, that implies from factor theorem, x minus 2 is a factor. Okay, now 2 is a 0 means f2 equals to 0. Okay, that way we will be able to find our k. Let's see. It means what I'm about to do here is a technique that we will use a lot in 3.3 or even after that. Okay, I basically put together the idea of 0, factor theorem, fundamental theorem of algebra, syntactic division. Okay, all of them actually put together in this one question here. Syntactic division, 1x cubed minus 2x squared minus 16x plus 16k. Okay, because 2 is a 0 means when I divide by x minus 2, the output should be 0. Is it okay? Now, later on, we will be able to find the k, but at the same time, we will reduce this polynomial degree of 3 into, when we divide by x minus 2, we get polynomial degree of 2. Okay, now if you are following me, and I hope you follow me, copy this first and then work it out. Work it out. So this is 1, 2, 0, 0, negative 16, negative 32. Now, the sum of these two guys has to be 0 by factor theorem. Okay, because according to factor theorem, that if c equals to 2 is a 0, x minus 2 is a factor. Okay, so the remainder has to be 0. Okay, now from there we found out that 16k equals to 32, k equals to 2. Okay, now furthermore, let me continue to the right-hand side. So our fx now is x cubed minus 2x squared minus 16x plus 16 times k. That's 32. And from that syntactic division, we saw that, remember that 2 is a 0. That's how we get the k, right? And that's how we get the constant for this polynomial. And we also know that x minus 2 is a factor. Therefore, if you divide by x minus 2, we get x squared plus 0x minus 16 as the other factor. See, x minus 2 is a factor, right? Okay, then when I use syntactic division, the quotient must also be a factor. So notice that I use syntactic division. To reduce from degree of 3 becomes degree of 2 once I know a 0. Once we get degree of 2, then we can go on either factoring it or complete the square or using formula to find the rest of the zeros. Now in this case, it's factorables. Okay, so the zeros are x equals to 2, that's the one given. X equals to negative 4, x equals to 4. Okay, now that's for number 39. I hope 3.1 and 3.2 becomes something quite strong for you. Let's take a break. We come back at 10:55. And at that time, we will go on to 3.3. Now, I'm aware that very likely you have not watched lesson 10. Very likely you have not watched lesson 10. But the 3.3 part that I will do later on is doable even without lesson 10. As far as I know, is even without lesson 10. Okay, basically whatever we have learned for now, okay, we can do the first part of 3.3. Okay, let's take a break first and then we come back at 10:55. So now I will continue with 3.3a. I will do only the parts that we can do so far. And those are questions number, so 3.3a that we can do so far are questions number, I will do number 2, number 6, number 9, number 11, number 13, number 15. I hope that's good enough. Yeah, I have only approximately 1 hour from now. Yeah, we can do more than that. You know what? Let me just write it down. So in case we have extra time, then I will do number 17, number 21, number 23, and then number 27, number 31. Okay, if we have more time. I'm not sure though. I'm not sure. But if I don't have time, then I will continue on this with this on Monday. Okay, now let's start. Number 2. What's the question number 2? We have a polynomial with degree of 3. And the zeros are -5, x equals -5, x equals to 2, x equals to 4. And we have other condition that f3 equals to -24. So let me use fx instead. Now we have a polynomial with degree of 3 and they give us 3 zeros. Solution. The zeros are x equals to -5, x equals to 2, x equals to 4. Now by factor theorem, then the factors are x plus 5, x minus 2, and x minus 4. Okay, such that the polynomial fx must be leading coefficient times x plus 5, x minus 2, x minus 4. Okay, we need to find this a. We need to find what is a. We need to find what's the a. Now, how to find that? Then we plug in f3. f3 is equal to -24, right? But at the same time, when I say f3, it means I input 3 into the function. Is that right? So -24 equals to a times 8 times 1 times -1. So -24 equals to -8a. Okay, therefore a equals to 3. Okay, now then our function, therefore, fx equals to 3 times x plus 5, x minus 2, x minus 4. Now, this is the polynomial in factored form. We already factor it. Okay, this is the polynomial in factored form. Now, suppose we want to write this in general form. Okay, I actually will accept this answer. If I ask you what's the function, then I will accept this answer. Okay, but this is a polynomial in factor form. What is polynomial in factor form? You have leading coefficient, okay, and each factor is linear factor, must be in x plus something or x minus something. Okay, must be x plus or x minus something, not 2x plus something, not 3x plus something. No, it has to be x plus or x minus something. Okay, now suppose I want that to be in general form. In general form, we basically FOIL that. In general form, that will be fx equals to 3 times, let me multiply from the back. Okay, that will be x squared minus 6x plus 8. And then I multiply that, I will get x cubed minus x squared minus 22x plus 40. Now, you may wonder how I can do it that fast without writing anything. Let me show you. Okay, only for those people who pay attention, or who really focus on my lecture. Okay, my x cubed is easy. It must be x times x squared. That's the only way to get x cubed, right? Okay, so that's why we get just x cubed. Now, how do I get that negative x squared? I get the negative x squared by imagining the following situation. The ways to get x squared are 5 times x squared, that's 5x squared, and x times negative 6x. Okay, so 5x squared minus 6x squared give me negative x squared. Now, how to get negative 22x? Then think of how to get x. It's x times 8. That's 8x. And 5 times negative 6x. Negative 30x, right? So 8x minus 30x is negative 22x. Okay, I teach this technique in my Algebra 1. After I taught them how to do FOIL, then I teach them this method. I call that fast FOIL method. Okay, not a lot of people can get it though in Algebra 1, but I do have more students able to do it in Algebra 2. Now, once you are in pre-calculus, I think you are mature enough, if you are studious, right? If you pass the class at your own right, not because of the mercy of your instructor, of your previous instructor, then you should be able to understand the fast FOIL. Okay, now then, let me go on. From here, we just multiply by 3. So 3x cubed minus 3x squared minus 66x plus 120. Okay, that's the general form. For number 2. Number 6, similar question, but this time they give us degree is 3. The zeros are x equals to negative 3i, x equals 3i, x equals to 4. And extra condition f negative 1 equals to 50. Now find the polynomial. Find fx. Solution. The zeros are x equals negative 3i, x equals to 3i, x equals to 4. Means the factors are, by factor theorem, x plus 3i, x minus 3i, x minus 4. And the polynomial fx must be leading coefficient times x plus 3i, x minus 3i, x minus 4. Now you will see a little fact much later on, something called conjugate zero theorem. I believe it's either in 3.3, very likely in 3.4. Conjugate zero theorem says the following. If you have a complex number as a zero, then the conjugate of that complex number must also be zero. Okay, to be more precise, if a zero is a number that has a conjugate, then the conjugate must also be a zero. Okay, but we will see that later on once we get to 3.4. Okay, now we want to find the A here. We want to find the A here. But before I do that, yeah, we can do that. F negative 1 equals to 50, right? But then when I plug in negative 1, I get 1 plus 3i, 1 minus 3i, 1 minus 4. Okay, so 50 is equal to A times, let me compute this. This is 1 squared minus 3i being squared times 1 minus 4 is negative 3. Now what I did here, actually, I see that as difference of squares. Okay, I see that as difference of squares. So 50 is equal to A times 1 plus 9 times negative 3. So that's negative 30, huh? Negative 30A. Did I make a mistake? Oh, negative 1. My bad. It's negative 1, not 1. Negative 1. Negative 1. So this should be negative 1 squared. It's still 1. But this one is negative 1. This is negative 5. Do that correction. Okay, so this is negative 50A. Okay, therefore the A equals to negative 1. Okay, now then the function fx equals to negative 1 times x plus 3i, x minus 3i, oops, and x minus 4. That's in factored form. Okay, but if I want to get the general form, then I will FOIL this. Let's FOIL this first. That's basically x squared plus 9. Okay. 3i squared, 3i being squared is negative 9. Okay. This is x squared minus 3i being squared. That's x squared minus negative 9. That's how we get that positive 9 there. Okay, then I FOIL that further. It will be x cubed, right? The only way to get x cubed is x squared times x. And then minus 4x squared plus 9x minus 36. So the polynomial will be negative x cubed plus 4x squared minus 9x plus 36. Okay, that's the general form. That's for number 9. Let's go on with number 6. Let's go on with number 9. Number 9. Find the polynomial. The degree is 4. Leading coefficient is 1. The zeros are x equals to negative 4 with multiplicity of 2 and x equals to 3 with multiplicity of 2 also. Okay, so this is the question. Find the polynomial fx such that with degree of 4 with leading coefficient 1 such that both negative 4 and 3 are zeros of multiplicity 2. So -4 and 3 are zeros with multiplicity 2. Sketch the graph of the function. Let's find the function first. So we have the zeros, x equals to -4 with multiplicity of 2, x equals to 3 with multiplicity of 2. Okay, so what are the factors? Then x plus 4 must be a factor with multiplicity of 2, right? X minus 3 is a factor with multiplicity of 2. So the function fx is a times x plus 4 squared, x minus 3 squared. Okay, but the leading coefficient is 1, right? The leading coefficient is 1. A sub 4 equals to 1. I use a sub 4 there is because this is degree of 4, right? Okay, a sub 4 is degree of 4, the coefficient of degree of 4. Now my fx is equal to x plus 4 squared, x minus 3 squared. That's it. That's the function in factor form. If you want to FOIL that, go ahead. I will do that later. Let's graph this first. Yeah, let's graph this first. We already have the zeros. That's really nice. Let me do it here. So these are this is the coordinate system. Okay, and the x-intercepts are -4 and positive, -4, 0 and positive 3, zeros. You can see the y-intercept later on will be 144, 0, 144. But how do you get that, Thomas? The y-intercept is when you plug in x equals to 0. You get 4 squared times -3 squared. That's 16 times 9. That's 144. Okay. Now then, you can imagine, you can do the sine graph first. If I were you, I would do sine graph first. But, well, this is positive. So between -4 and 3, supposed to be positive, right? Okay. Now, but -4 is a 0 with even multiplicity, right? -4 is a 0 with even multiplicity, which means that to the left of -4 is the same sign to the one to the right of that. Okay, likewise for x equals to 3. That's what the graph looked like. Okay, now it is possible that the graph actually look like this. Instead of like that, it may look like this. In other words, we don't really know where's the peak here, where it reached the maximum. It may be there, maybe like this. Okay, but that discussion, where is the peak, the local maximum of that polynomial, is something we will see in calculus. It's beyond our level yet at this point. Okay, but that's approximately the sketch. Now, if you want to see more detail, you can do the sine graph, right? -4 and 3. Okay, this is positive, like the y-intercept is positive. Okay, and all the critical numbers are even multiplicity. So this function is always greater or equals to 0. Okay, now suppose we want to FOIL this. Suppose we want to FOIL this, then in general form, then we will get x squared plus 8x plus 16 times x squared minus 6x plus 9. The first term is x to the 4th. Okay, now what is the coefficient for x cubed? X cubed can only happen if we have x squared times 6x and 8x times x squared. Okay, that will give us 2x cubed. Now, how about x squared terms? X squared terms must be this guy, that's positive 9 minus 48 plus 16. Okay. 9 minus 48 plus 16. I wonder what's that? That's 41. Negative 41. No. My bad. It's not. Minus 25, so that's negative 23. So this is minus 23x squared. Now, how about the x terms? The x terms will be this guy times 9 and this guy times negative 6. Okay, that is 72 minus 96. That's negative 24. Negative 24x plus 144. Okay, that's the function. Okay, let me ask you to try number 11. Is it one of the questions I want to go? Yeah, number 11. Let me ask you to try number 11. I give you, let's say, 5 minutes for this. I say number 11, I wrote 13. Number 11, the degree is 6, okay? The zeros are x equals to 0 with multiplicity of 3. That's easy, right? And x equals to 3 with multiplicity of 3 also. And f2 equals to negative 24. Okay, find the functions. Okay, and sketch that if possible. Okay, you may want to do the sine graph first. Let me ask you to do this in maybe 6 or 7 minutes. So 11:28, we come back. So the question is find the function and sketch the graph. Find fx and sketch. Find fx and sketch. So solution. We know the zeros are x equals to 0 with multiplicity of 3 and x equals to 3 with multiplicity of 3. So the factors are x cubed and x minus 3 cubed. Therefore, the function fx equals to a times x cubed times x minus 3 cubed. Now I need to find the leading coefficient. So negative 24 equals to f negative, no, not negative 2, f, just f2 equals to a times 2 cubed times 2 minus 3 cubed. So negative 24 is equal to a times 8 times negative 1 cubed, which is negative 1. Okay, so negative 24 equals to negative 8a, that's a equals to 3. Now then continue a bit here. Oops. What happened? So we have fx equals to 3 times x cubed times x minus 3 cubed. Or 3x cubed times x minus 3 times x minus 3 squared. Okay, so I deal with the square first. Okay. And then later on I multiply by x minus 3. X squared minus 6x plus 9. That's 3x cubed times x cubed. Minus 6 minus 3, that's minus 9x squared. How about x? 9 plus 18, that's 27x minus 27. So the functions fx in general form is 3x to the 6 minus 27 x to the 5th plus 81 x to the 4th minus 27 x cubed. No, 81 x cubed, I mean. 81 x cubed. So I forgot to multiply by 3. Okay, that's for number 11. Number 13, I think I would just do up to number 15 at most. Yeah, according to my plan. Yeah, number 13. Now we see the graph. We are given the graph and we need to find the polynomial. The question is find a polynomial fx with degree of 3 with the following graph, with whose graph is as the following. Okay, so in other words, can you find the functions from the graph? If we are given the graph, can you find the function? Okay, and you will see what we really care are actually X-intercept and Y-intercepts. Okay, so the X-intercepts are -1, 0. The Y-intercept is 0, 3.5. Okay, X-intercept 1.5, 0. And another one is 3, 0. Okay, the graph looks like this. That's what the graph look like. So what we will do, we will reverse engineer that, right? Okay, we'll reverse engineer that. But we basically have all the informations like the one we have in number 11 and number 9. Okay, so for example, we have degree of 3, right? We have degree of 3. Okay, the X-intercepts are -1, 0, 1.5, 0, 3, 0. Thomas, we have X-intercepts only though, but we don't know the multiplicity. We don't know the multiplicity for each. You're right, we don't know the multiplicity of each. But because we have 3 X-intercept and they told us the degree is 3, then it must be simple multiplicity for each. Okay, each of them has to be degree of 1, right? Because the degree of the polynomial is 3, therefore it should have only 3 zeros, right? Okay, the zeros x equals to -1, x equals to 1.5, x equals to 3. Okay. Again, why then all the multiplicity has to be 1? Well, if we don't know the degree, suppose we don't know the degree of 3, right? Then the degree here, okay, we still see that as degree of 1. Why? Because it crossed the x-intercept kind of like a line. It crossed the x-intercept like this, or it crossed x-intercept like that. Okay. Now, if it were degree of 3, then it will cross the x-intercept like this. It's curvy. It's curvy around the x-intercept. That's how we know that the x-intercepts are from the zeros with degree of 1. Okay, are from zeros with degree of 1. Let me erase all of them. Now then, because those are the zeros, then the factors are x plus 1, x minus 1.5, x minus 3. So fx equals to a times x plus 1, x minus 1.5, x minus 3. Okay, now then the y-intercept is 0, 3.5. So f0 is 3.5, which is a times 1 times -1.5 times -3. Right? So 3.5 is equal to 4.5a. Okay, so 3.5 over 4.5. Don't use calculator. Once you use calculator, you just lose it. It will be a very long decimal. Now, instead, think of this: how to make the denominator becomes an integer. Well, that's 4.5, right? Okay. You can change all of these numbers in decimal in fractions. So you can write it this way: the 3 half is 7 over 2. 4.5 is 9 over 2. Right? Okay, which is 7 over 9. Okay, that's one way. Another way is 3.5 over 4.5. You multiply the top and the bottom by 2. Okay. Now, basically, you don't make it that decimal simply because you have calculator. Then you think, oh, I can use calculator, but then it's a lot of rounding error. Okay, no, so don't use calculator. Okay, don't use calculator to compute and get a decimal. Fx therefore equals to 7 over 9 times x plus 1 times x minus 1.5 times x minus 3. Okay. Again, it may be beneficial if you see that 3.5, you make it 7 half. When you see that 1.5, you make it 3 halves. Then it will make your computation a lot better and more accurate. Okay. Number 15. Number 15, the last one that I will do. Okay. Again, the degree is 3. Find the polynomial, find fx, whose graph is shown as follows. I try to replicate the graph we have on our textbook. We have y-intercept 0,3, x-intercept 1,0, and 3,0. In fact, the graph actually bounds at 1,0. Okay, it bounds at 1,0. So find the function. Well, solution. We have the x-intercepts from the graph are 1,0, 3,0. Okay, so the zeros are x equals to 1, x equals to 3. Now, the thing is, we have degree of 3 though, but n equals to 3. And you see, and we see that around 1, the critical number 1, the sign on the left and on the right are the same. Right? Okay. So the 0 x equals to 1, x equals to 1 is a 0 with even multiplicity. Can we just say that x equals to 1 has degree of 2, multiplicity of 2? Well, you need to argue why it's 2. Okay, you need to argue why it is 2. Well, we only know that it's even for now. Okay, now since the degree is 3 and x minus 3 is a 0 with odd multiplicity. In fact, we can tell straight from the graph that it is with multiplicity of 1. Then the other two zeros are at x equals to 1. So when 3 is a 0 with multiplicity of 1, right? You're supposed to have a total of 3 because degree of 3. Okay, so the other two zeros must be here, right? Okay. Now from there we say then x equals to 2, I'm sorry, x equals to 1 is a 0. What happened? 1 is a 0 with multiplicity of 2. In other words, our zeros now are x equals to 1 with multiplicity of 2 and x equals to 3 with single multiplicity. Therefore, our factors are x minus 1 with multiplicity of 2 squared, right? And then x minus 3. Therefore, our fx must be a times x minus 1 squared times x minus 3. Now, we know that the y-intercept is 0,3. Therefore, f0 is equal to 3 also at the same time, equals to a times 3 minus 1 squared. Oh, hold on. Yeah, and then No, 0 minus 1, not 3 minus 1. 0 minus 1 squared and 0 minus 3. So 3 equals to a times -1 squared times -3. That's basically -3a. From there, we see that a equals to -1. Finally, so our fx is -1 times x minus 1 squared x minus 3. Now let's FOIL that. This is x minus 2x plus 1 times x minus 3, which is equals to -1 times x cubed minus 3 minus 2 minus 5x squared, 6 plus 1 plus 7x minus 3. Okay. Now our textbook actually gives us this answer. Our textbook gives us this answer. Our textbook gives us answer in factored form. Okay, but if you want that to be in general form, it will be -x cubed plus 5x squared minus 7x plus 3. Okay, that's the general form. I still have a couple minutes. Let me do 1 or 2 more problems. Number 17. Actually, you can see number 17 is a lot easier than what we have done in this section. Okay, because what? The question is quite simple. Let fx equals to x squared, 3x plus 2, and 2x minus 5 cubed. Okay, is that the question I need to do? Number 17? Yeah. So I can do number 17 and 21 actually. And the question is find the zeros and its multiplicity. Find the zeros and the multiplicity for each. They already factor it for us. That's the good news, right? So we can just get the zeros right away. So the zeros are from x squared. The zeros are x equals to 0 with multiplicity of 2, right? And then x equals to -2/3 with multiplicity of 1. And x equals to 5/2 with multiplicity of 3. That's it. We are done. Number 21. We have let fx equals to, they don't really factor it for us in full, but it's good enough. X squared minus 3 being squared. Okay, find the zeros and the multiplicity of each. Solution. We will factor that further. So fx equals to x squared minus 3 being cubed, right? Now I will factor this x squared minus 3 further. Okay, or you can find the zeros if you want. Okay, you can just find the zeros. Let's find the zeros. Let's find the zeros. Okay, so x squared minus 3 equals to 0, x equals to 3, x squared equals to 3, then x equals to plus minus 3, plus minus radical 3. Okay, but because of that cube, then each of these will be multiplicity of 3 each. Okay, so the zeros are x equals to radical 3 with multiplicity of 3, x equals to negative radical 3 with multiplicity of 3. That's it, we are done. Okay, let me just stop here, and I hope Monday, Wednesday class and Tuesday, Thursday class also can watch this before you continue with lesson 11. Okay, that's for today. See you then on Monday.